Chapter 3, Part 3, Balancing Equations. You guys should have practice at this. It should not be bad, so this should be more of a review than anything else. All right, let's look at consider the formation of water. From hydrogen and oxygen gases, we get H2O. Like all reactions, this one requires bonds of hydrogen and oxygen to be broken, the atoms rearranged in a certain ratio, and then the bonds formed again. If we look here, we see that it's basically is not balanced. We have an extra O. So what do we need to do to balance this equation? We need to change the number of our molecules that we have. So here, now instead of starting with just one H2, we're going to start with two of them. So we're basically going to take, or each H2 is going to take an oxygen, and they're going to go and they're going to form two water molecules. So now our balance formula would be 2H2 plus O2 yields 2H2O. Very, very simple. Again, you might say, well, wouldn't it be easier just to put a 2 on the outside of the O? They don't have to worry about stuff in the front. No. Once you've written out, we call this the skeleton structure, where there's no coefficients written out, we just have balanced formulas. Right? H2, that's the balanced formula for hydrogen. O2, that's the balanced formula for oxygen. H2O, that's the balanced formula for water. We can never change those when we're balancing an equation. All we can do is write coefficients out front. So this we would never do. All right, try an easy one here. Again, check to see if it's balanced. If it's not balanced, then we need to change coefficients to a different number. We see here we have two H's on the left, only one on the right. So I need to put a big 2 here. Again, I can't put any subscripts. I can only put big coefficients there. So now my H's are balanced. I have 2 Cl's on the left. I have 2 Cl's on the right. Again, this coefficient of 2 goes to the hydrogen and to the chlorine. You could put 1s here if you want. You don't need to put 1s. If there's no coefficient written in front, it's understood that there's a 1 there. All right, I'll give you a second here. Try a few more easy ones. You can pause the video. I'll give you some time. Go ahead. All right, if we take a look, the first one, nice easy one. I see my NAs, I have 1 on each side. CLs, I have 2 on the left and only 1 on the right. So I got to put a 2 in front of my NaCl. Now when I put that 2 there, that changes my number of Na. So now I have to go back and put a 2 in front of my Na. Second example, my Fe's look good. However, I have 8 S's on the left. I need 8 S's on the right. So I put an 8 in front of my iron sulfide. So then I have to put an 8 in front of my iron. Third example here, my mercuries are okay, Hd is okay, except my O's, I need to put a 2 there. That's going to change the number of mercuries. Last example, I have 2 Cl's on the left, only 1 on the right. So I'll put a 2 there. That gives me 2 Na's on the right, so I need 2 Na's on the left. There's 2 I's on the left, 2 I's on the right. Good. Nice, easy ones. All right, a couple hints. Hint number 1, when you have 2 of one thing on the left and 3 on the other side, try to get them both up to 6. So here we see oxygen and ozone. Ozone is O3. Now I have 2 on one side, 3 on the other. So what I'm going to think about doing is making 6 on each side. I put a 3 in front of the O2, a 2 in front of the O3. Over here, my ALs, I have 1, 2, so I put a 2 there. My O's, I have 2 on the left, 3 on the right. So now, again, my hint is to make 6 on each side. So I put a 2 in front of my aluminum oxide, a 3 in front of my O2. Now, by putting that 2 there, that changes my number of ALs. Got to cross off my 2 and change that to a 4. Again, take 2 extra seconds when you're done, or when you think you're done with the balanced equation, and just do a quick atom inventory. What's on the left needs to be what's on the right. Down here, the formation of ammonia. This is ammonia, the NH3. I have 3 H's on the right, 2 on the left. So I need to put a 3 in front of the H2, 2 in front of the NH3, and now that balances out my equation. So again, hint, if you have 2 and 3, try to get 6. Hint number 2, worry about oxygens last, and sometimes hydrogen. We do this because oxygen is very reactive and it tends to form a lot of different compounds. So like in our first example, it's in all 3 of those compounds. So if you were to change one of them, you're changing the oxygens. So you don't even worry about the oxygens until the last element. First example, we have 1 Ca here, 1 Ca here, good. 1 C on the left, 1 C on the right, 3 oxygens on the left, 1 plus 2 is 3. So that's balanced as it is, with just 1s written across there. All right, let's look at our next example. This is a combustion reaction. We have a fuel plus oxygen. When we're burning something, we get carbon dioxide and water vapor. So let's look. Carbons, I have 1 on the left, 1 on the right. That's good. Hydrogens, I have 4 on the left, only 2 on the right. So I'm going to put a 2 in front of my H2O. Now I can count up my total oxygens. I have 2 plus 2. Remember, don't forget to distribute this 2 to the O. So there's 4 total on the right. I need to put a 2 in front of my O2 to get 4 total on the left. And then I'm balanced. Next one here is combustion of glucose. C6H12O6 plus O2 yields CO2 plus H2O. Again, the oxygen is in everything, so even changing one thing is going to always change the oxygen, so we worry about that last. All right, I have 6 carbons on the left, so I need to put a 6 in front of my CO2. I have 12 hydrogens. I need to put a 6 in front of my H2O. Now I need to count up all my oxygens. I have 12 here. 6 times 2 is 12. 6 times 1, 6. So I have a total of 18 oxygens on the right-hand side. On the left-hand side, I have 6 here. I don't want to put a coefficient out front because that would then change my carbons and my hydrogens. So if I have 6 here, and I know I need a total of 18, 6 minus 18, 18 minus 6, I need 12 oxygens here. They come in pairs. So I can put a 6 in front there. Again, worry about the oxygens last because it pops up a lot.